Today, we'll be talking about finding areas between two curves. Suppose you're given a random given here and it was graphed like this. Let's talk about the two elements. Firstly is the vertical element. Secondly is using the horizontal element. So something like that. So firstly, for the vertical element, let me just draw a zoom in scale of one of this. And so let us call this vertical element. Why? Because it is vertical for convenience sake, and it has a thickness of dx because this is a horizontal thickness. So in order to find the area for this, you must find y upper and y lower. In order to find the y upper here, we will find it based on this graph. Since it touches this line, this is the y upper. And let us subtract it by the one that is touching the lower part of y, which is this curve right here. That curve. Of dx. And in order to know what the upper and lower limit would be, it would depend on what element you would use. Since you are using a vertical element right here, you will move from right here, right to left. But you must know that is based on the x-axis. So something like this. Let us call this B. And let us call this point A. So this is the first formula for when you're using a vertical element. For the second one, for the horizontal element, let me just make a zoom in again. Let us call this X for convenience since it is also a horizontal element. And let us call this thickness of this dy. So in order to calculate the area for this using a horizontal element, we must know how to use this x right and x left. In order to know the right side that touches x, it is this curve right here. And so the formula for this would be x right. And for the x left, just see what the left part of your x element is touching, which is this line or curve. Of dy. And in order to find out what the upper and lower limits of this, since you are using a horizontal element, you must go up to down. So in here, this should be in the y axis value. So let us call this d, and for this one, since this is the lower limit, let us call this c. And so these are the two formulas that you can use. You can use either horizontal or vertical element based on what is the simpler mode. Let us try some examples. Suppose you are given these two curves or one line, y equals x squared and y equal 4. How to find the area of this? First of all, we will need to graph it. And so, firstly, how can we graph this? We can first use the table method for this one. This is y equals x squared. Using the table method, just put random simple values of x, such as -2. If x here is -2, -2 squared would be +4. Remember, this will be something like that, so it is +4. If x here is -1, -1 squared is simply 1. If x is 0, 0 squared is 0. And so if x is +1, it is also y would be +1. And if x is 2, y also would be +4. And so we can plot this first. So something like that. If x is -2, y would be +4. X would be -1. Y would be also 1. If x is 0, y is 0. So something like graph of this. This is the graph of y equals x squared. And so, let us move on to y minus 4. Y here is only equal to 4 since this is a line. Just find y equals 4. 1, 2, 3, 4. This would be it. So this is the line of y equals 4. And so, the next step right here would be to find the points of intersection. So we can equate this to each other since they are both y. So this would be x squared equals 4. The square root of 4 would be equal to positive or -2. And so if you plug in 2 in here, 2 squared would be 4. So that is the value of y. And if you plug in -2, it will still be 4. And so these are your points of intersection. And it proves that it is correct because as you can see here, the points of intersection right here would be equal to 2 and 4. And for this one, it is also equal to -2 and 4. Now that we have all our given in this graph, we can now solve for the area. And so we can either use a vertical element or a horizontal element. If you use a horizontal element, you can see here that it touches the same curve, the y equals x squared here, and it will be a complicated solution. So we will just use a vertical element here since it touches two curves right here, the y equals 4 and y equals x squared. So we will just adopt for the simpler method. And so if we are using a vertical element, something like that, you must know that based on the formula, it is y upper minus y lower of dx. This is y upper, and this is y lower of dx. And so, what touches the y upper of this? It is this curve right here, y equals 4. So, the value of y here would be equal to 4 minus the value of y lower, which touches this curve. And since this is y equals x squared, the value of this would be simply x squared of dx. And so, we can find now the value of upper and lower limit. Since this is a vertical element, we will need to find it based on right to left. So for this right here, it touches the value of 2 of the x-axis. And if you go into the left, the value of this would be negative 2. This is also one of the advantages of using points of intersection, because you can now identify the upper and lower limit of the integral. So this would be negative 2. And so, by integrating this would be 4 minus x squared of dx. Integral of 4 would be 4x, and integral of x squared would be x cubed over 3, with the upper limit of 2 and lower limit of negative 2. And so, substitute this first into all x values. So this would be 4 multiplied by 2 minus 2 cubed minus 3 minus 4, and substitute this lower limit next, multiplied by negative 2 minus negative 2 cubed over 3. 4 multiplied by 2 would be 8. 2 cubed would be 8 over 3. 4 multiplied by negative 2 would be negative 8 minus negative 2 cubed would be negative 8 over 3. And so, 8 minus 8 over 3, this would be 24 minus 8 over 3 minus negative 8 minus negative 8 over 3. This would be equal to negative 16 over 3. Or if you want the manual method first, this would be negative 24 plus 8 over 3. (24 minus 8 would be 16 over 3 minus negative 24 plus 8 would be negative 16 over 3. And so, distribute the negative here. So, this would be 16 over 3 plus 16 over 3. Final answer here would be equal to 16 plus 16 would be equal to 32 over 3 square units. Number 2. Y equals x and y equals x squared. First, let us graph this. Y equals x, this is just a straight line. And y equals x squared, this is simply just an exponential function. If you want the table method, it is like this. If x is 1 right here, y would be 1. If x is 2, y would be 4. And if x would be 3, y would be 9. So it will be something like that. And so we can now solve the points of intersection. Since these are also both y, we can just equate this to each other. So this would become x equal x squared. Move x to the other side. So this would be x squared minus x equals 0. Factor out x right here. So this would be x multiplied by x minus 1 equal to 0. And so x either would be 0 and x would be equal to 1. If x is 0, substitute either of this. Y would be equal to 0. And if x is 1, y here would be equal to 1. And so the points of intersection would be 0, 0 and 1, 1. So this point right here would be equal to 1 and 1. And in this point, it would be 0, 0. So let us now use either horizontal or vertical element. As you can see here, if you use a vertical element, it touches the two curves, so it's no problem. And if you also use a horizontal element, it also touches the two curves and it's no problem. So you can either use either one of them. And so what we're going to just use here is to use a horizontal element. And so the area for this would be equal to the integral of x right minus x left of dy. And let us see the value of this one. And so first let us find the x right here. So x right, it would be this one. So it would be the curve of y equals x squared. But since we are talking in terms of x right here, we must get the value of x. So this would be x squared equal y. And put the square root of this. So this would be square root of y. So the value of this would be square root of y minus x left right here, which would be this red line, which corresponds to y equals x. Since it is already in x form, the value of this is simply just y. So in order to find the upper and lower limit, since this is a horizontal element, we will talk in terms of y value. In this one, the y value of this would be 1. And the value of this one would be equal to 0. Let us simplify this. This would be upper and lower limit of 1 and 0. Integral of square root of y minus y of dy. And so, integral of square root of y, this is simply y raised to the power of 1/2. So add 1 to this. And in the fraction, copy this format. And so answer would be y equals 3 over 2 over 3 halves. And we can put 3 halves at the top. So your final answer would be equal to 3 over, this should be 2 over 3 multiplied by y raised to the power of 3 over 2 minus integral of y, it is simply y squared over 2 with the upper limit of 1 and lower limit of 0. And so first, let us substitute 1 into this equation. So this would be 2 thirds. Y is 1 raised to the power of 3 halves minus y squared would be 1 squared over 2. Minus, we can now substitute 0 into this equation. 2/3 of 0 raised to the power of 3 halves minus 0 squared of 2. You can see here, the answer right here would be equal to 0. So just cancel that. Simplify this. 1 raised to the power of 3 halves would be simply 1. And so this is simply 2/3 minus 1 squared would be 1 over 2. And so by fraction, this would be 3 times 2 would be, 2 times 2 would be 4 minus 2 times 1 would be 3. 3 times 1 would be 3. And the common factor would be 6. And so this would be 4 minus 3 would be 1 over 6 square units. Next example, y equals x squared and y equal 2x. So graph this first. For y equals x squared, we know that is an exponential graph. Something like that. And y equal 2x. For y equals 2x, we can use the table method. If x here is 1, 2 times 1 would be 2. If x right here would be 2, y right here would be 4. And if x right here would be equal to 3, y right here would be equal to 6. So let us plot this. So this would be 1, 2. Let's just estimate this. And if x is 0, y also is 0. So this would be in here. Be something like that. And so we can calculate the points of intersection in here. Since these are also both y, just equate this. So this would be x squared equal to 2x. Put 2x on the right side, left side I mean. We can factor this out. X multiplied by x minus 2 equal to 0. So x would be 0 and x would be positive 2. If x is 0 right here, y right here would be equal to 0. If x is 2, substitute this, y right here would be equal to 4. And so the points of intersection would be 0, 0, and 2 and 4. This right here would be 2 and 4. And in here it would be 0, 0. So we can choose either of the element again, but today we will use vertical element. So this would be b and this value would be a. Since this is on x-axis, upper limit would be 2 and lower limit would be 0. So area right here would be integral of b and a of y upper minus y lower of dx. So this would be y upper, what it touches right here would be equal to y equals 2x. So what it touches right here on the top is this line right here. It would be 2x minus value of y lower. It touches this red graph. So this corresponds to y equals x squared of dx with the upper limit of b which is 2 and lower limit of a which is 0. of dx. And so integrating this, integral of 2x would be 2x squared over 2, or simply x squared, minus integral of x squared would be x cubed over 3, with the upper limit of 2 and lower limit of 0. Substitute it. This would be 2 squared minus 2 cubed over 3. And if you can see here, if you substitute 0 into these two values, it will also equate to 0. So no need to put it to save time. 2 squared would be 4, minus 2 cubed would be 8 over 3. 4 multiplied by 3 would be equal to 12 minus 8 over 3. So this would be equal to 4/3 square units. For the next example, y equal 3 and x squared would be equal to y plus 1. So first let us put this y equal 3. It is just a line. So this would be this. And x squared equal y plus 1. And so if x right here would be equal to 1, so this is 1, and since it has a 1 here, put it outside, put it on the left side, this would be equal to 0. Let's just like rewrite this in order to be simplified. If x is 2 right here, it would be 4 minus 1, which would be 3. And if x right here would be equal to 3, 3 squared would be 9, minus 1 would be 8. If x right here would be 0, 0 squared, it would be equal to 0 minus 1, so this would be negative 1. If x is negative 1, negative 1 squared, it would be simply be 1. So it's something like that. And so, in order to find the points of intersection, first, we must equate this all to y. Since this is already equal to y equals x squared and 1 minus 1. So this would be 3 equal to x squared minus 1. Move 3 to the other side, so you would have x squared minus 4 equal to 0. So x squared would be equal to 4. And so x right here would be equal to positive or minus 2. If x right here would be positive 2, y value would be 3. And if x right here would be negative 2, y is still positive 3. And so these are the points of intersection. And so by graphing this, so it would be something like this. So it would be something like that. So the points of intersection, it would be positive 2, 3. And this would be negative 2, 3. This curve right here represents x squared equal y plus 1. Or we can put this as y equals x squared minus 1. And so, if you will be using horizontal element, you can see here that it touches two curves and it will result in a complicated solution. So no need to do that. And so just use a vertical element right here because it is much simpler. And so the value of here would be in here. And since this is on x-axis, get the value of x right here. And so the upper and lower limit right here would be equal to positive 2 and negative 2. Integral of y upper minus y lower of dx. Y upper right here, it touches this line. It is equal to 3 minus y lower. It is equal to this graph, x squared minus 1 of dx. Simplify this. It would be 3 minus x squared plus 1. 3 plus 1 would be equal to 4. Of dx. Now we can start integrating this. Integral of 4 dx would be 4x. Integral of x squared would be x cubed over 3. And so substitute the x values. So this would be 4 multiplied by 2 minus 2 cubed over 3. And subtract this by value of putting the negative 2. Four multiplied by 2 would be 8 minus 8 third minus negative 8 minus negative 8 third. So what you have here would be equal to 24 minus 8 over 3 minus negative 24 plus 8 over 3. And so you would have 16 minus 3 minus negative 16 over 3. This should be positive now. And so the final answer right here would be equal to 32 over 3 square units.